Good morning, students. So this is the last topic from module number 1. So that is macroprocessor algorithm and data structure. So here we are having two varieties. In case of a macroprocessor, we can design it for two-pass assemblers, and also we can go for single pass or else pass one assembler exactly. Okay. So in this today's session, we'll be discussing regarding if you are designing a macroprocessor for pass one, then what all the procedure we need to handle, and what all the algorithms or data structure we need to use. Regarding that, we will have a glance. Then if it is in the case of pass two, then what are the consequences we need to face? Regarding that also we will discuss. Then one more thing we are going to discuss, like if the macro want to define another macro, okay, means nested macro procedure, if it is available, then how to deal with that? Okay, then what will be the gesture of those nested macro? Okay, that also we will be discussing in today's session. Okay, and we'll be discussing a few data structure. Okay, so which is handling for the main, which is handling for the arguments. Okay, and for the definition. Okay, so three data structure also we need to study in that. Okay, it's a very simple topic. So design can be done as two pass or a one pass massive. Okay, so we can go for either two pass or one pass. Both are possible. Okay, so we'll be discussing regarding a two pass assembler first. Okay, so if you want to design a macroprocessor for two pass assembler, okay, so we are calling it as two pass macroprocessor. Okay, if you are designing a macroprocessor for two pass assembler, okay, means after computing the pass one, we are computing the pass two. Okay, if that is the case, then we are calling our macroprocessor as what? Two pass macroprocessor. Okay, you might design a two pass macroprocessor. Okay, for that, first we need to handle the pass one, later we need to handle the pass two. Okay, so what we should be done in case of pass one? Okay, process all macro definition. Right? This is all macro definition. As you know, the macro definition should be available in the beginning of the program. Obvious. Okay, so whenever we have the beginning of the program, there itself will be having a definition of the macro exactly. Okay, so that should be handled by pass one. Then during pass two, expand all macro invocation statement. So wherever you are calling that macro for the expansion, the body of the program, there it should be expanded. Okay, so two passes we are having. During one pass, we need to process all the macro definition. During second pass, we need to expand it. Yeah, okay. However, one pass may be enough because all macros would have to be defined during the first pass before any macro invocation got expanded. Actually, pass one is enough for this, okay, because it is defined in the beginning itself. Later we will be going for the invocation. So wherever you are pass one assembler find that macro definition, so all the parameters, all the body of the macro, everything will be known for him. Okay, so in the future, wherever it is encountering that macro call, in place of that macro call, it can easily replace the macro body. Okay, but still, if you want to go for pass two, okay, then there will be a two split. Okay, pass one will be handling the macro definition, pass two will be going for expansion. The definition of the macro must appear before any statements that invoke that macro. This is a restriction. Okay, in pass one and pass two, in both sides we are having this restriction. Like whenever we are trying to invoke that macro, then first it should be defined. Okay, later only we can go for invoking them. Moreover, the body of one macro can contain definition of the other macro. So this is what we are calling it as nested. Okay, means we have one macro body. Okay, so inside which we are defining one more macro. Okay, nested macro. Macro inside one more macro. Okay, such that. Okay, so consider the example of a macro defining another macro. So in this example, we are taking the name of that macro, first macro as macros. Okay, capital it should be macros. Okay, which we are designing it for SIC machine. Okay, in case of SIC XE, macros X we are calling it as. Okay, so that will be the standard for SIC XE machine, but here we are using macros exactly. Contains statement that defines read buffer and write buffer and other macro instruction for SIC machine. So in this example, just observe this. example. In the next slide we have, okay, macros for sick machine. So here we are using a macro keyword or a directory, okay, which is defining macros as a definition. Is it right? Okay. So he is going to end, this macros is going to end over here, amend, right? End of macros. But just observe, right next to that, we are calling one more macro directory, okay, which is defining read buffer. Then later after a few lines, it will be terminated, amend, okay. Then again you are calling it write buffer, okay. So using the macro directory, okay. Then again amend directory will indicate that read buffer is terminated. Then later few lines of macros are available over here. At last, amend it. So this is what the procedure. If you want to call or if you want to include the macro definition of one with another. Yeah. Okay. Then that was how we are dealing the multi-pass or two-pass assembler or two-pass macro processor. We'll go for one-pass macro processor. So one-pass macro processor that alternate between macro definition and macro expansion in a recursive way is able to handle recursive macro definition. See, first time when it is encountering the macro definition in the beginning of the program, so we are just updating the definition table. So in this slide itself, at last you can observe, okay, we are having something called as a definition table. Okay, next slide we have argument table, we have name table. Okay, so we are dependent on few data structure, okay, to handle this macro processor using one pass. Okay, so recursively we will be executing or recursively we will be calling for the expansion of the macros over here. So for handling that, we need to go for the few data structures over here. Okay, we'll see that what are those data structures. So restriction, what we have over here is the definition of a macro must appear in the source program before any statements that invoke that macro. Okay, see, in the beginning of the program itself, we need to have a definition of a macro. Later in the body, you can, if you are expecting the invocation like expansion, then it is possible. Okay, but if you are trying to reverse, like definition will be after the invocation, then it is not possible. Okay, but that may be possible in case of pass 2, because in pass 1, we are just scanning the program, okay, to identify the definition. Then in pass 2, we are going for invocation, then in different area. So this restriction does not create any real inconvenience. Okay, so that it doesn't matter. Okay, the design considers in so is for one pass assembler. The data structure required are first one definition table we are having. So what is this definition table? Stores the macro definition, including macro prototype and macro body. Okay, so here whatever the macro definition we are having, like the complete body part, okay, which is beginning at the macro and which is ending at the amend example. Okay, see, sorry, this portion, we are calling it as a macro body example. Okay, so the beginning and the end, okay, both are managed over here. Then comment lines are omitted. Okay, restriction or reference to the macro instruction parameters are converted to a positional notation for efficiency in substituting arguments. Exactly. See, we are having one more table called as argument table. Okay, here what we do whenever we find these kind of arguments in the macro definition. Okay, so according to their positional notation, we will be storing them. Okay, so while expansion, we are retrieving these arguments from the argument table and it will be substituted for the expansion exactly. It will increase the efficiency. Okay, so that is the job of definition table. Then name table, it will be just holding the name and starting and end of the macro. Okay, so name table we are having, one tab we call it as stores macro names, then serves as an index to test tab. Okay, where exactly this particular definition is available. Okay, regarding that, the complete information will be available over here. The pointers to the beginning and end of the macro definition. Okay, so that indicates where exactly the macro definition is starting, where exactly the macro definition is ending. Okay, so that information will be available in non-tab exactly, because we cannot restrict the user like we need to provide only one macro definition. No, okay, we can go for hundreds of thousands of macros. Okay, then in macro definition, we'll be having the declaration or definition of hundreds of macro expansion over there. Okay, so for searching them it will be difficult, so we need to have some index. Okay, like from where to where which macro is available. Okay, for that non-tab will be utilized exactly. Then argument table or ARG table we call it as stores the argument according to their position in the argument list. As the macro is expanded, the argument from the argument table are substituted for the corresponding parameters in the macro body. The figure below show the different data structure, okay, describe and their relationship. Okay, so here we have just observe. So this is what the definition table. So here, whenever we find the macro definition in the initiation of the program, so everything will be loaded. Okay, same prototype. So here, read buffer, MM. Okay, later write buffer, write MM. Okay, subscribe. So where exactly it is beginning, where exactly it is ending. What is the name of this macro? Read buffer, right? So beginning at this particular point, ending at this particular point. That address will be managed by numpad exactly. Okay. Then later, what all the parameters you are using from buffer length, okay, subscribe, what all parameters you are using, everything will be managed in argument table exactly. Okay. So this is what the data structure and how we are dealing with the macro. Okay. So this is the end of module number 1. So the next session we'll be discussing the linked list. Sorry, not linked list. Sorry, loaders and linkers. Sorry, students, loaders and linkers exactly. Okay, thank you.